This session is based off the learnings I've had over the years and something I wish I had when I started my cloud journey many years ago. Even if you have been using the cloud for many years, there might also be some interesting bits of information for you. Hi, and thank you for joining the session today, starting your AWS IAM journey. I'm Pierre Little, and I'm the security lead for the customer engineering team across APJ. When you see this star in the presentation, that means there is an extra tip for you, either a pro tip or a new service feature, so keep a lookout for the star. Traveling your identity road paves the way for a great journey, and what's interesting about this picture are the trees on either side of the road. These trees are banyan trees, and they have a unique ability to grow roots down from their branches, providing additional support as the tree grows older. These trees can live for hundreds of years, clearly outlasting you and me. Your identity foundation lays the groundwork for a legacy, and as we continue to release new services and features, your foundation will continue to grow and support your cloud journey. When we are thinking about identity and access management, the question we are trying to answer is who can access what, and what is the best way to deliver least privilege access. Your cloud identity is the starting point for building your zero trust network. In this mental model of identity, access, and resource management, the who consists of the name, credentials, metadata. The can access is about the policies and compliance. The what is about isolation, grouping, tagging, and sharing. For example, governance could determine if someone can connect to an external IDP for identity, or have some level of guardrails around how resource sharing works, or perhaps to gather and present information on who can access what. And so each of these fall into identity, access, and resource management, and governance can be considered across all three. AWS has a range of services to help you in this space to achieve your objectives. You want to pick the right tool for the job. You use the indicator on the left to align with what you're looking to do, then identify the accompanying service on the right to do that with. This presentation is predominantly focused on governance, workforce identity, and access management. Not much consumer identity such as Cognito, but many of the concepts may still apply, such as identity, policies, and access. For today, we're going to take a brief look at AWS Organizations, AWS Single Sign-On, as they are important to achieving your identity and access management goals for enabling fine-grained access control. Let's start to take a look at the who part of the question. I want to introduce an account. This is important because accounts help with the who part of the question. One of the ways in which customers can have both speed and security is by utilizing accounts. Customers sign up for AWS by creating an account, and then they start building resources and deploying services within the account as they build their environments. Accounts are essentially resource containers that assist customers in managing AWS resources. As needs and demands grow, environments scale by adding new accounts. This is a best practice because it enables rapid innovation across distributed teams and individuals. It reduces the blast radius, and the accounts can be adjusted to meet new business processes based on operational, regulatory, or budgetary requirements. Costs are incurred at the account level, so activity and costs can be identified with each account. And you manage your AWS service limits at an account level. What I mean by this is that if you want to increase the amount of EC2 instances you want running in your account, you increase the EC2 service limit. Yes, users, groups, roles, and policies also exist in an account. AWS Organizations, or AWS Orgs, allows customers to centrally manage and govern these separate accounts. AWS Orgs does more than just managing identities and permissions. For example, you can view and set your service quotas for new accounts in your organization. Set policies for all accounts in your org, simplify resource sharing, and have a complete overview of your spend across all your accounts. Okay, this is fine at a high level, but let's look at some specific examples of things that orgs can help you with to apply across your AWS orgs. Don't worry about writing the URL down. I have all the links together for you at the end of the presentation. AWS Orgs enables you to organize accounts and manage their relationships. Your accounts can be organized in a way that is already familiar to you. Ovals represent organizational units. You can also set policies that apply to all accounts underneath them in the AWS organization. This enables you to set up guardrails that enables your teams to innovate within the account boundaries. Scaling through account creation is a best practice because it provides many benefits. Firstly, it enables rapid innovation across distributed teams and individuals. Similar to how you can spin up EC2 instances in minutes, you can create and provision new accounts and AWS resources for teams in minutes. It's worth noting that not all customers start with a single account. Some customers may migrate to AWS and set up multiple accounts to start with, so they can achieve the same benefits we describe here. In summary, you can centrally provision accounts and resources, share resources and control access to accounts, regions, and services, secure and audit your environment for compliance, optimize costs and identify cost-saving measures. AWS offers AWS Single Sign-On and supports users from Active Directory that can be on-prem or AWS Directory Service for Microsoft Active Directory, also referred to as AWS Managed Microsoft AD Service. Yes, you can join your Office 365 identities with AWS SSO. AWS has also added support for creating users in native AWS SSO Identity Store. With SSO, you can centrally manage access for your users across AWS accounts. Users can single sign-on to all the AWS accounts you've granted them access to, as well as to hundreds of SAML-based SaaS applications, such as Jira, Slack, or ServiceNow. If you don't have any accounts and looking to get started with this, take a look at AWS Control Tower. I want to demonstrate the sequence customers follow for multi-account management and app management. First, you choose your identity structure, much like we just covered in the previous slide. Secondly, build out the permission sets for these identities, and then thirdly, assign those permission sets to the identities and the selected accounts. Permission sets are just a collection of policies. For your applications, points 4 and 5, configure them with SAML and grant access to identities to access these applications. Having just covered off the who with accounts, AWS Organizations, and AWS SSO, the next part of the question we dive into is answering the can access what. For access management, you have a bunch of guardrails that allow permissions. But if I don't have a policy that grants it, then that permission is denied. So really, we want both. Here is an example. A policy is an object in AWS that, when associated with an identity or resource, defines their permissions. AWS evaluates these policies when a principal, the who, uses an IAM entity, the user or role, to make a request. Permissions in the policies determine whether the request is allowed or denied. Actions or resources that are not explicitly allowed are denied by default. There is a link to get you started with these policies, and the AWS Samples GitHub repo has some example guardrails already available for you to review and use. We are first going to take a look at grants. This is likely what you are more familiar with. Identity-based policies attach, manage, and inline policies to IAM identities, users, groups to which users belong to, or roles. Identity-based policies grant permissions to an identity. Resource-based policies attach inline policies to resources. The most common examples of resource-based policies are Amazon S3 bucket policies and IAM role trust policies. Resource-based policies grant permissions to the principal that is specified in the policy. Principals can be in the same account as the resource or in other accounts. Access control lists, ACLs, are used to control which principal in other accounts can access the resource to which the ACL is attached. ACLs are cross-account permission policies that grant permissions to the specified principal. ACLs cannot grant permissions to entities within the same account. Here we take a look at some of the available guardrail policies you can use. I need you to stay with me on this. The first one might already be familiar, as we spoke about AWS Organizations earlier. An organization's SCP, or service control policies, can be used to define the maximum permissions for the account members of an AWS organization or organizational unit, OU. SCPs limit permissions that identity-based policies or resource-based policies grant to entities, the users or roles, within the account, but do not grant permissions. Tag policies are a type of policy that help you standardize tags across resources in your organization's accounts. In a tag policy, you specify tagging rules applicable to resources when they are tagged. For example, a tag policy can help specify cost center tag you want on resource. We're going to explore more of this later on. AWS Backup enables you to create backup plans that define how to back up your AWS resources. The rules in the plan include a variety of settings, such as the backup frequency, the time window during which the backup occurs, the AWS region containing the resource to backup, and the vault in which to store the backup. You can then apply a backup plan to groups of AWS resources identified by using tags. Backup policies in AWS organizations combine all of those pieces, making it easier to manage across your AWS organization. The effective backup plan for each AWS account in the organization appears in the AWS Backup Console as an immutable plan for that account. You'll be able to view it, but not change it. AWS supports permission boundaries for IAM entities, that's the users or roles. A permission boundary is an advanced feature for using a managed policy to set the maximum permissions that an identity-based policy can grant to an IAM entity. An entity's permissions boundary allows it to perform only the actions that are allowed by both its identity-based policies and its permission boundaries. Session policies. Session policies limit the permissions that the role or the user's identity-based policies grant to the session. Session policies limit permissions for a created session, but do not grant permissions. A lot of interesting information here. Come back here to listen again if you didn't get all of that. We know now there are two main sets of policies, guardrails and grants. Remember, we're always working towards least privilege when we're answering who can access what. I have a Banyan bonsai tree at home, and for me it's about ensuring I have the right tools to look after my Banyan bonsai. Customers tell us that they desire to grant their employees least privilege access, which is the right access to the right things at the right time to do their job, but nothing more. How do we go about working towards least privilege? We continue to introduce new services and features, and this is an example of the evolution based on customer feedback. Your account serves as a boundary for blast radius containment. I mentioned this earlier in the presentation when covering off what is an account. Assign your users to IAM roles via federation, thereby ensuring you don't create additional unnecessary users. With this method, you're following best practice by reducing the use of long-lived credentials used by individuals. You now know about using permission boundaries for your guardrails. You can refine the permissions you've granted with Access Analysis tool. I'm going to show you how to do this a little later. Lastly, you have attribute-based access control. And when you hear this, I want you to think about tags and your tagging policies we mentioned previously. And yes, I do have an example to show you. Managing identities is just a part of the equation. For resource management, you're likely to encounter dozens, if not hundreds of accounts. This is very common. We encourage the use of multiple accounts for workload segmentation. Depending on what you're doing, you could have thousands of resources across your account estate. And with that many Amazon S3 objects, and even more objects in DynamoDB, the challenge here is ever growing. The number of resources can add complexity. Your complexity might not be as high, but the point is that scale is going up and to the right. This means that we need to have a more scalable way of managing resources that isn't always at the individual resource level. Tag policies is a new feature that allows you to define rules on how tags can be used on AWS resources. You can use tag policies to easily adopt and standardize your approach for tagging AWS resources. With tag policies, you have a simple way to consistently apply tags, enforce allowed tags, audit tag resources across your entire organization. As you know, tag policies are integrated with AWS Organizations. You can apply a tag policy to your entire AWS organization, specific organizational units, and to individual accounts. After applying a policy, you can export a cross-account, cross-region report to easily aggregate, view, and share this data with resource owners to correct the non-compliant tags. Also, you can optionally specify enforcement to prevent non-compliant tag changes. Standardized tags enable customers to confidently leverage tags for critical use cases such as cost allocation and attribute-based access control, because you can ensure your resources are tagged with the right attributes. Here we're showing the developer can only access resources that are tagged blue. Take note the deliberate spelling error that would otherwise cause this guardrail to fail. Now, with identity access and resource management, as we showed in the 3 pillars, we have come full circle to show the ability to provide fine-grained access control. AWS provides granular controls and has provided roles-based access control for years. But managing this at scale can at times get complex. Wouldn't it be nicer if you could express an access control rule in a more human, understandable policy? Wouldn't it be cool if those rules automatically scaled and adjusted as the properties of your users dynamically changed? What about an example? All engineers who have taken the course hiring can access all buckets tagged recruiting. An hypothesis, security rules that are simple enough for humans to easily understand will lead to the best overall security. In this example, we build the policy for the developer to access EC2 instances in a particular subnet in an approved region as a condition. You now know that policies are available, but how do you know which policies work best against which service for your use case? This is your go-to page. The AWS services listed are grouped by the AWS product categories and include information about what IAM features they support, like service, action, resource level permissions, resource-based policies, authorization-based tags, temporary credentials, and service link roles. So you know about the policy categories, how to leverage attribute-based access control with tags, and which IAM feature works with which service. So let's take a look at the policy structure. Here is an example of the IAM policy structure. The policies can include multiple statements, and each statement has a specific structure. The way I remember the structure is by the abbreviated SE PARC. For SID, that's the statement identifier, then the effect, principle, action, resource, and condition blocks. Not making sense yet? Let's take a look at an example. This example shows how you might create an IAM policy that allows IAM users to change their own AWS Management Console password on the My Credentials security page. This AWS Management Console page displays account and user information, but the user can only access their own password. Here we see the statement identifier, what effect we want, what action we want the user to take on which resource. Then we also have a second part. After allowing read access to the policy, we allow the user to get information and change the password, only if the resource they are changing is the same as their username. Let's do one more example to ensure these routes take hold. This example shows how you might create an IAM policy that allows an IAM user to start or stop EC2 instances, but only if the instance tag owner has the value of that user's username. See the condition we used? This policy also grants the necessary permissions to complete the action on the console. Pro tip, make sure you verify who has access to modify tags Otherwise, this could lead to a broken dependency with individuals changing tags to gain access to other resources. How do we learn more about what security considerations we should review or how to write these policies? Let's take a look. Once again, the documentation is your friend, and this example I'm highlighting is a new condition key we recently released for S3 that filters access by the AWS account ID that owns the S3 resource. Some additional global condition keys we have are the ability to control access based on source IP address, time of day, or whether the user used multi-factor authentication to log in. Whatever you do in the space, keep it simple and use this flowchart to help guide your logic when building your policies. Remember, first principles, it's basic string matching, allow, deny, IAM user or org level policy, etc. We start with a policy that if it grants no access will deny access, otherwise proceed to the next evaluation step. Verify the SCP guardrails. Validate the resource-based policy grants. Confirm any guardrails from the IAM permission boundaries, or any other restrictions from the session policy. And lastly, inspect your identity-based policy grants. We stepped through the identity access and resource management, and now you're up and running in the cloud. Let's not forget what the question is. Who can access what? So what tools are available to help us with solving this question? If you want help with building policies, take a look at the AWS Policy Generator, or just head over to the IAM console and start building. You start by selecting the service you want to interact with. Then you build out the statements for the policy with the guided options available and click Generate Policy. I've already built my policies, and with the IAM Policy Simulator, you can test and troubleshoot identity-based policies, IAM permission boundaries, Organization Service Control Policies, SCPs, and resource-based policies. In this example, I have my user PLCLI selected on the left, and then in step 2, I choose the service and the actions I want to test the current permissions against. And then step 3, I choose Run Simulation. The results below show what is allowed or denied against the user and their assigned permissions for that service and actions. From this result, you can take action to scope the permissions appropriately. How else can you remove unused permissions? For users, you can review the last access timestamp. For a role, you can review the last use timestamp. And then again, from this result, you can take action to scope the permissions appropriately. For a role, we list the roles available and then review the last use timestamp on the right to see what permission can possibly be safely removed. For the users, select which user you would like to review, then choose the Access Advisor tab, which will show you the last access timestamp for a service that can be safely removed. IAM Access Analyzer uses automated reasoning to look for new and updated IAM policies, and it analyzes the permissions that they grant. You can review the findings and modify the policies if necessary to maintain least privileged access. IAM Access Analyzer helps you identify potential security risks in your AWS environment by analyzing the resource-based policies applied to resources within your zone of trust. When Access Analyzer identifies any policy that allows access to those resources by a principal that isn't within your zone of trust, it generates a finding. We have extended IAM Access Analyzer to also review resource-based policies for Secrets Manager. This allows you to discover if your secrets are publicly accessible or accessible from other accounts. IAM Access Analyzer now enables you to validate access before deploying permission changes. You can prevent public and cross-account access before you set permissions. You can preview findings and validate that your policy changes grant only intended access to your resources. You can preview and validate public and cross-account access in Amazon S3 console or with AWS IAM Access Analyzer APIs. Let's step through completing a simple analyzer. With 3 simple steps, we first choose the organization we're looking to run the analyzer against and click Create Analyzer. The second step is to select the finding that has been produced, and the third step is to review the finding and take action where appropriate. Here you can see that another account listed as external principal on the right-hand side has access to my resources listed in the middle. For me, this is expected as per my cross-account access, so I won't need to take any action on this other than archive the finding. Here you can see I'm modifying an S3 bucket policy. Yes, if you look closely, you will notice I'm using the source IP condition key I mentioned earlier to restrict access. Below the policy is where you can now go to Access Analyzer and run the analyzer as we saw previously and review the findings. Access Analyzer is a new feature of IAM that continuously monitors and analyzes access control policies to help teams centrally identify resources accessible from outside an account. It will analyze policies from S3 buckets, KMS keys, SQS queues, IAM roles, and Lambda functions. All possible access paths are verified by mathematical proofs done by a type of cognitive science called automated reasoning. It's fast and is able to quickly analyze thousands of resources in just a few seconds. It's comprehensive. It's not just using historical access to predict the future, it's using mathematics to comprehensively assess all access paths. It's the first service powered by automated reasoning now available to builders everywhere, offered by AWS. And it's free, available to you for free within the IAM console. You can also find it via the AWS S3 console and Security Hub. We covered off understanding the who can access what question with going through what options are available to you with AWS SSO, AWS Organizations, policy categories for guardrails and grants. We looked into policy structure with supporting examples and how to verify service adoption against IAM policies, as well as how to think about the policy evaluation logic. Having the right tools for the job is important, and we reviewed 3 IAM tools to help you remove unnecessary permissions, ensuring you can achieve least privilege access. Much like this beautiful banyan tree, with this identity foundational knowledge, your workloads have the right support to continue to grow and support your business needs. All those interesting links I shared earlier are all together to make it easier for you to access and learn more. You join the AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS Training and Certification for Security. According to the global knowledge, IT decision makers report having the most difficult time finding qualified cybersecurity talent. So training has never been more important. We offer more than 25 digital and classroom courses for you and your teams around security, identity, and compliance. You can also showcase your expertise by pursuing the AWS Certified Security Specialty Certification. If you want to go and build right away, head over to the AWS Well-Architected Labs for resources to help you get started. Thank you for listening and learning. Before you go and enjoy the rest of the summit, please submit your feedback.